too bad. We're doing imaginary numbers, but we're basically like adding, subtracting, and multiplying with imaginary numbers. So yeah, it's going to be fantastic. Woo! Anyway, you know what an imaginary number is?
No.
They're kind of silly. Just to let you know.
Kim, I'm gonna grab my
Yep. I should have my mask on. Yikes. Whew. Well, here we are.
Yeah.
Okay. So imaginary numbers, we have them for a specific reason, and we could have seen them last section when we were solving quadratics. So, imaginary numbers, they are represented by I. So if you ever see an I, that's technically an imaginary number, so they're not real, unfortunately. So when we were like classifying numbers, we had 6 different types of real numbers. We had like integers, rational, irrational, whole numbers, all the things. Imaginary is not part of that list. Because they're imaginary, so you can't even like graph them on an XY plane. Yeah. So imaginary numbers come from taking the square root. So I can only square root a certain type of number. What numbers can we technically square root?
I'm asking for perfect square.
Okay, so I can square root perfect squares. I would get out like a whole number. What other kind of numbers can I square root?
Real numbers.
All real numbers?
Whole. Integers.
What can I not square root technically?
Negative.
Okay, so I can't square root negative numbers. How do I even say this? I'm going to say the square root of negative. So this is not possible. So basically, I actually is equal to the square root of negative 1. So if you ever get a square root underneath the radical sign, you can take the negative sign out and replace it with the letter I. And then you can simplify the radical like we did the last section. So we're going to be solving quadratics like we did last time. So getting x squared by itself, and then square rooting, we're probably going to get out an imaginary solution this time. Okay, so here we have this. We want to solve 2x squared plus 18 equals negative 72. So since I just have an x squared term, I can get the x squared part by itself. And I can move all the numbers and other things over. So I don't need to factor it, because I don't have x squared and x. I could try if I wanted to, but I don't even want to try. But what do we do first?
Subtract 18.
Yeah, so if you add 72, you're trying to factor. I don't want to factor, I just want to get x squared by itself. So then negative 72 minus 18 is negative 90.
Then you divide by 2.
Okay. So I have x squared equals negative 45. Dylan, you should get off your phone. Yeah. Okay, what would I do to both sides?
Square root.
Okay. So now I need to simplify the square root of negative 45. And technically I have plus or minus this. So I could take the negative sign out of the square root symbol and replace it with the letter I. And I still have 45 underneath it. But can I simplify the square root of 45 like we did in section 5?
No.
There's no perfect square that divides into 45.
Yeah, they're probably.
There probably is.
Perfect.
So like perfect squares of 4, 9, 16, 25, 36, 49.
Oh.
What?
4, 9, 5.
Yeah, 5 and 9. So I can rewrite the square root of 45 as the square root of 9 times the square root of 5. This is using that product property. I could break it into 2. So I know the square root of 9 is
3.
3. So I can write 3i. The square root of 5 can't be simplified, so you just leave it. Square root of 5. So this is my answer with an imaginary solution. Aren't those nice?
It's really not that hard.
I mean, we did that before. It's just moving the I in front. Okay. We have another piece. Complex numbers, and we have properties. This isn't anything new either because we're just like combining like terms. And we know how to combine like terms. So a complex number, we want to write complex numbers in the form a plus bi. So they say a is the real part. So it's just going to be like a number or a fraction or anything. It won't have any imaginary piece to it. Bi is the imaginary part. And we technically always write it in this order, so the real part and then plus the imaginary part. Nothing too crazy about that. Okay, so we just run to write it. This would be like standard form of a complex number technically. I don't need to say anything else about that. Okay, we have properties. So technically, complex numbers, since it's a plus bi, I could add them together. So I could do a plus bi plus c plus di. So then I can like regroup things. So I can combine the real parts, the a and the c. And I can combine the imaginary parts, bi plus di. Right, it's basically just collecting like terms. It's nothing interesting. Difference works the same way. So I can subtract two complex numbers. Same thing, we're just like regrouping things, so combining the real parts with the imaginary parts. And last one, we're doing product today, we're doing quotient on Monday, because quotient is more complicated, just like square roots is more complicated when we're dividing. Sadly. So I can multiply complex numbers together. So basically, you're going to distribute this. So FOIL it out, distribute, whatever you want to call it. But the main piece that I'm concerned about is when we multiply bi to di. So b and d would be numbers that you just like multiply together. But then I have I times I, which is I squared. And so technically I squared represents something. Does anybody remember what I was actually? Okay, so I can place I with the square root of -1. This is now raised to the second power because it's I squared. So what happens to the square root and the squared? They cancel because they're like inverses of each other. So then I just have the -1 coming down. So we know I is the square root of -1. Now we know I squared is -1. These are two pieces that you should know. Okay. So we're going to do some examples. Are you good, Gracie?
What was that tough part you just did? Like from the.
So when we distribute, we're going to get out this I squared piece. And we can replace I squared with -1, basically. So now I squared is -1, I is the square root of -1. Okay. So we're going to combine these together. Combine like terms. So I'm adding. So what two numbers can I combine first?
So I just missed that one.
That's okay. What numbers can I combine? Okay. So the real numbers are 12 and -8. And 12 plus -8 is 4. And I combine the imaginary part. The -11 plus 3 is. Yay. So this can't be simplified. This is just my answer. That's how easy those are. Don't get those wrong. Seriously. What? Oh my gosh.
Who's it gonna be?
All right. Here's the next one.
We can combine the real numbers.
Okay.
Or wait.
You said there was 4 minus 8, right?
So the real part.
35 minus 13.
Which is
22.
fantastic.
4i plus I.
Okay, this one we have to be careful.
4i squared.
Yeah.
5i.
Okay, so since 4i is in parentheses, we're technically subtracting 4i. So it's -4i plus I.
-3.
-3i.
Wait, why is it -4?
Because this minus sign right there is going to both the 13 and the 4i, because those were in parentheses. Yeah, so this is final answer. Can't you find anything else? That's the piece I see most people leave out, is the subtraction sign to both terms. So I've seen that happen before. Adding, I usually don't see anything messed up. Unless you like add 2 and 2 you get 5. Which is possible. Okay,
Alright.
next one, multiplying. How would I multiply this if it was just like variables and stuff?
This is just very
So we're going to do the same thing. Treat I as variable and distribute.
-40i minus
What?
plus 45i.
What is I times I?
I squared.
I squared. Okay, so -40 I can't do anything with, but I squared represents something.
-1.
Yeah, I squared is -1, so I'm going to replace that.
-40i minus.
Oh gosh, forgot the I. And then if I wrote it in standard form, technically the real part's first, and then the imaginary part, so it should be -45 minus 40i. Just flip them around. Still not too shabby.
No.
Distribute. We know how to distribute. Replace I squared with -I. That's the new part, but that's not anything hard. Okay.
Why did you go for
Complex numbers, if you write it in standard form, the real part's first and then the imaginary part. Technically, it's not wrong if you have it the other way, but if they ask you to write in standard form, it should be in order. Okay, where do you want to start with the next problem?
Do like that distribution.
distribute things, so like FOIL, or distribute, or whatever you want to call it. Whoa. So negative 8 times 4 is
32. Sorry. It's Friday.
it is Friday. Negative 8 times negative 7, 9.
56.
2y times 4.
8.
And then 2y minus or times negative 7, 9.
Negative 14x squared.
Okay. So now we just need to simplify all this together.
56.
38.
Okay, so those are like terms. 56 plus 8 is. Okay.
And then I squared equals negative 1, so replace it.
Yeah.
And that'd just be 14.
So I have negative 32 plus 64i plus 14.
Add 32 and 14.
Yeah.
What?
What is that? No.
18. Negative 18.
Oh, interesting. Yeah.
And then flip them around. Oh, never mind.
Yeah, it's already in the correct one. I was playing in the head on that one.
Yeah, that's easy.
Woo.
Oh, no, please tell me there's no story problem.
I actually deleted the story problem out.
Thank the Lord.
Yeah, you're welcome. I didn't like it, so I was like, nope.
Why wouldn't I like to?
Yeah.
There's the one on our homework. It's on to North for Megan's.
I don't know. There might be one.
I don't know, maybe.
I mean, it's hard to do story problems with imaginary numbers because they're imaginary. So they're not real.
You can't make it
Yeah,
story problem.
not really.
Yes.
And still might